Hello guys, and welcome back to the second part of how to create a state-of-the-art game engine. My name is Christian, and before we start I just want to press the issue how important it is to separate your logic from the data. Any developers out there writing any application, this is something that you should always do no matter what, period. It's so important. It helps a lot. uh, Cleaning up your application and keeping things separate. At least, at least you should do this. Um so let's take a look at our architecture we spoke about in the first tutorial. In this video we're going to implement the model, and with the model comes of course the interface to the model and the model listeners as well, which is our observer pattern. So the iModel will be used by the other parts of the system that needs a direct access to the model. They will never get a direct access to the model itself. They will only get access to the interface model, or the interface to the model. And then for the system independent parts, to keep the coupling loose, we will use the observer pattern to let data flow through the different parts while keeping things separated and isolated. So let me start Visual Studio. So I will select a new project. I will just name it AE Engine. You can of course choose whatever name you like, and I will not use any precompiled headers because computers today are so fast, so you won't really gain anything by using them. And here we have got our empty project. So the first thing I'm going to do is create filters. This is just to keep the different files in some sort of order within the Visual Studio project. Create a filter for model, view, controller, and the logic. So basically we're creating one filter for each system you see here. We want to also have a file directory that follows this that lies close to this architecture, so we know which files are belonging in which directories. So I will also create the filters for the header, model, view, and controller, and logic. So let's select our model and create a new file. The first file I'm going to create is the CPP file, and now I actually have to create a new directory, because filters just is a Visual Studio thing. You have to create your own directories as well. So my file is going to be stored in aengine/model, and I'm going to name it model. And now going to the header files, I select the model filter and I create a new item, and I select the header file, also naming it model, creating it in the model directory here. So we're going to add new or more header files. This is going to be our interface to our model, so it's going to name it iModel, where I stands for interface. And for our observer pattern we also need a iModel listener. can actually just rename it to observer to make it more clear that this is an observer pattern. So let's start with the imodel.h, our header file for the interface. So all model header files should have a definition to avoid circular includes if not defined. I'm going to prefix everything with AE. If not defined AE model H, define AE I model H, and this will prevent us from including or getting duplicate classes even if we include the iModel header from different parts of the program. We want to be using we want to declare everything in here in our namespace, so we have to write namespace and I'm going to select AE as a namespace, and I will create the iModel class. Just checking that everything compiles fine. So what we want to do with our interface to a model, we know that we want to register observers. We also want to be able to create and destroy objects or game entities. So let's start with since this is an interface denoted by iModel, all the way that you make interfaces in C++ is making all virtual functions pure virtual functions. So if you create a virtual void create object, we can ignore the arguments for now. So this is a virtual function. The difference between the virtual functions and the pure virtual functions is that a virtual function you can choose when you inherit the iModel, you can choose to override create object if you want. If you create a pure virtual function, which you do by assigning its body to 0, is saying that since the body is 0, the function that inherits the iModel has to implement the create object. You cannot just ignore it. You cannot choose to not implement it. So let's also have a destroy object. So this will allow our logic layer or tier to create and destroy objects in our model. So let's go over to our model.h. So we want to be careful here to correct the definitions here. We're now working with the model, not the iModel. So we're going to use the same one here. If not defined aModel.h, define aModel.h, and we're using the namespace AE, and we're going to use the class model. And now we're not going to have virtual functions. We're going to have actual implementation of these. So we remove the pure virtual function calls. And we're also adding a constructor and a deconstructor. Now you have to be careful. Now we know that we're not going to inherit from the model, but if we're going to make a something that inherits from something else, in order for the destructor to be called when the object is deleted, we have to declare the model as virtual. Otherwise this destructor will only be called in in the top inherited object. But we don't need to do that, so we can ignore that and move on. It's why is it complaining here? Is something wrong? Let me try. Well, it seems fine. So let's go to the model. We choose to include the eye model, the interface. Oh, sorry. We're going to include the model. Now, when you do an include, you should be very careful, because each time you do an include, you are creating a dependency. And as long as the dependencies are staying within the same tier, it's usually okay. For example, the model can, without any problem, include the eye model or the model listeners or anything model related here. The danger is when you include files from other parts of the system. Then you're creating a real dependency. So you should keep that to a minimum, which this architecture help us do. So we're including model. We are taking these functions here. They are defined within the AE namespace, so we have using namespace AE, so it can find those. Now let's define these. And for now they will just be empty functions. And it should all compile. And it says, of course, we have made a mistake here. We need to end if here, and we need to end if there. And now it should compile. Yeah, that's great. So let's copy the code from the eye model again, paste it in, and now we are working with the eye model observer. It's using a class eye model observer. And now we need to create a number of callbacks. For example, we want to know when an object has been created or destroyed or changed. And these will also be virtual function calls that forces whatever that inherit this to actually implement them. So we have the case when an object is created and when an object is destroyed. We want to add, later on we're going to add arguments to this, and also have a case when a property has been changed or an object has been changed. But we're going to leave that for later on. Now, in the model, we also want to be able to register observers. So in our interface to model, we want to define a new function which is register observer. I also forgot all these virtual interface calls will be public. In interface classes, all the pure virtual calls or functions are by default, or by the definition of the interface, a public accessible. So we need to define those as public, and we also need to define that as public. Now since we defined that we need to have a register observer function here, we have to define it in our model, and we will actually take arguments here. We need to include the I model observer, and we need to take a pointer to a observer. And we need to change this function as well in the model observer. So we might have an error here, syntax error. It doesn't like this, I model observer. Why? Because we don't include, yeah, forgot about this. We need to include the I model, and we also need to extend it. The model needs to inherit from the I model, stating that this is a interface. The model is the model has an I model interface. An if-def mismatch. We have one too many here. And of course we have defined this function, so we have to implement it. So going to the model, and we have to implement it here. And now it should all compile fine. Of course we need to do something here. We cannot just leave this one empty. We need to have a list of observers that we can iterate through when stuff happens. So I'm going back to the model.h, the module header file, and we're going to have a private section here where we will be using the standard template library, the include a list, from there. And since we don't really want to be using namespaces, importing namespaces in header files, because that could create a mess from other parts, including those header files, we have to spell out the whole namespace here. It's a list of iModel observers. I'm just going to call it observers. Like that. Going to compile that. Working fine. So let's move on to the model CPP file. Now, when something registers as observers, we just get the pointer to the observer here and push back in our list. So each time someone register, it will be added to the list, and each time an object is created or destroyed, we want to iterate through all of the observers and call the object created or object destroyed callback. So we need an iterator. Going back to the model, and when we create a model or create an object, we're going to set observers iterated to observers begin. and while observers it is not equal to the end of the observers, we are going to increase the iterator. Oh, I forgot that. And we're also going to call, I go back to the iModel observer, we're going to call the object created callback here. I need to get the iModel observer, need to get the pointer from the iterator observer is, and I need to dereference the iterator to get it like that. And now I can call the object, because now C++ knows that this is a iModel observer. And that should compile. That's good. And let's do the same when an object is destroyed. But of course we're going to call object destroyed instead. So now we have the skeleton file for our model. We're going back to our main function. So let's take a look at the architecture again. The main function is the only place where you create the different parts of the system. It's only the only part of the system that needs to know the different implementations behind those parts. It doesn't and with implementation I mean, for example, if you have a view, does it render, is it an OpenGL view or a text-based view or a DirectX view? So the rest of the system don't need to care, because they only see the interface to the view. But the main function is the part where everything is tied together. So we need to include the model, we need to include the interface to the model, and we need to include the implementation of the model here. We will also be using the namespace AE. So let's create the model, an instance of the model. We're not going to save it in the model, in a model itself, but rather in the interface model. So iModel model equals, I have to cast it to an interface model. New model. Let's see if this works. It worked fine, and you can cast safely your model to an interface model, because model here inherits the interface model. And later on, when this part is going to give a pointer to the model to the rest of the system, they're going to perceive it as an iModel, which keeps the implementation, the real implementation hidden. And this is together with this and the observer pattern, it makes our different parts of the engine loosely coupled and isolated from each other. So next video we're going to implement the next part of our game engine, so stay tuned for more.